Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, my group and I will going to present about copper as electrical conductors. So today, the presenters are Taibah, Ikri, and me, Akila. We are from Group 10, Lecture Group 19. Before we start, you need to know what is a conductor. So, a conductor is a material that allows electrons to flow freely from particle to particle. Conductors can conduct and transmit heat or electricity. Next, you need to know what is a good conductor. A good conductor is a conductor that has small resistance, which means the smaller the resistance of a conductor, the better the conductor is. And if the conductor have a bigger resistance, that is not a good conductor. Next, you need to know what is a copper. So a copper is a metal that is made up of copper atoms, which are closely packed together. So if you are wondering, copper atoms position in the periodic table, so copper is located at period 4. Period 4. This one is period 4. And copper is in group 11. So here, this is copper. So that is the position of copper in the periodic table. Next, I have some fun facts about copper. So average home contains 181 kilogram of copper. This one will be explained more on the application of copper. Next, copper is 100% recyclable, which means you can recycle copper and 80% to 95% of the recycled copper will be used back. The last fun fact is copper is important for our body to make red blood cells. So I'm going to pass the presentation to the next presenters. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Iki Zulfiami Baharuddin and I will continue this presentation. So, why is copper better than other metals? First, copper has high melting point, which is 1083 degrees Celsius, and it has boiling point has been 2595 degrees Celsius. Because of electricity has voltage that release heat, copper can resist it, so it can be used for a long time and save money. For example, if we look at this picture, it is Turkish coffee. Turkish coffee brewing is one of the oldest forms of coffee brewing. It's been around since the early 1400s. They use scrap metal and hot sand. Due to copper has a high melting point, it can still be solid and conduct the heat and boil the coffee. Second, copper doesn't corrode. Copper is a low in the reactivity series. This means that this doesn't tend to corrode. This is important for its use for pipes, electrical cables, saucepan, and radiators. They can be bent to fit around corner. The pipes can be joined by soldering and they are safe in fire because they don't burn or support combustion. The only other material that has similar resistance to corrosion is stainless steel. However, its thermal conductivity is 30 times worse than copper. That is why copper is better. Lastly, copper has one free electron, so it's easier to conduct compared to magnesium, which have two free electrons. Each copper atom has lost one electron and become a positive ion, so copper is a lattice of positive copper ion with free electron moving between them. The electrons are a bit like the particle of a gas that is free move within the surfaces of the wire. The electron can move freely through the metal. For this reason, they are known as the free electrons. They are also known as conduction electron because they had copper to be a good conductor of heat and electricity. That's all for me. Thank you. Next to Taibah.
Assalamualaikum and hello everyone. I am Taibah and now I will be talking about my part of the presentation. Let's take a look at the structure of a copper-63 atom. This is the diagram of the structure of copper-63 atom. The nucleus consists of 29 protons and 34 neutrons. The red-colored spheres are the protons and the green-colored spheres are the neutrons. There are 29 electrons which occupy available electron shells. The electrons are the purple-colored spheres which are orbiting around the nucleus. There are 4 electron shells around the nucleus. The first 3 shells are fully occupied with electrons. There is only 1 valence electron sitting in the 4th shell. So, the valence electron can easily jump from one atom to another, leaving the copper atom slightly positively charged, which means there will be more protons than electrons in the atom. The positively charged copper ion will have a tendency to draw other electrons to fill the space in the outermost electron shell. So what this means is, the valence electron in the fourth shell here, this valence electron, the distance between this valence electron and the nucleus is very far. Therefore, the force of attraction between the valence electron and the nucleus is weak, and the one valence electron can easily escape the atom. This will attract other electrons to occupy the empty 4th electron shell. And next is, how does copper conduct electricity? Let's find out together. So here we have a diagram of a piece of copper bar. As you can see, in this copper bar, there are multiple copper atoms. The purple spheres are the copper atoms and the tiny gray spheres are the electrons. Previously, we looked at the atomic structure of copper and saw that there is only 1 valence electron, which is the free electron, because those electrons are free to bounce from one atom to another atom, and the electrons drift around. So how can we turn these drifting electrons into electricity? First, we take the copper bar and we bend it around so that it forms a loop, and we connect both ends of the loop to a dry cell or a battery. When the circuit is energized, the electrons are going to move in a specific direction, meaning that they will no longer drift around randomly. Since electrons are negatively charged, they will be attracted to the positive terminal of the dry cells. Electrons will flow from the negative terminal to the positive terminal. That means from here, the electrons will flow in this direction to the positive terminal. See, like the electrons are flowing in this direction from the negative terminal to the positive terminal. So when there is electron flow, electric current is formed, but the flow of electric current is in the opposite direction, and that is how electricity is formed. What are some of the applications of copper conductors? So the first application is electrical wiring. As the copper wires are ductile, they can be bent and the copper wires also have low resistivity. Like what Akila stated in her fun fact, the average home has about 181 kilograms of copper. This is because most houses use copper wires in their electrical wiring. Copper conductors are also used in power distribution because they conserve space, minimize power loss, and they also maintain lower cable temperatures. Copper conductors are also used in communications because they have suitable tensile strength. Lastly, copper conductors can also be used as a magnet wire because they produce a magnetic field when electric current flows through it.